All right, so today we're going to be working with something a little bit more complex. The last couple of days we've been working on pre-algebra stuff, going into algebra 1. This is going to be algebra 2, going into college algebra. So this is quadratics, dealing with quadratics. So a quadratic equation, how can we tell it's a quadratic equation? Well, because of the leading number here, it has a variable squared. So if we have a variable squared, plus a number with a variable and a constant, then we have a quadratic equation. It's also going to be set to 0 like that. Okay, so this is almost a quadratic equation. We could even set it to 0 here if we wanted to. But if you notice, there's extra numbers here that we have to deal with, right? We have a minus u plus 6 squared. We have to undo all that, figure out how it fits into our equation, and then get our equation back to this standard form, much like it is now, and then we can solve the equation. So we've identified it as a quadratic equation. It's in the right form, most of it, at least the first 3 terms, but now we have to get this last term here unfoiled and figure out what to do with it. So let's start to do that first. So what I'm going to do here, when I say unfoil, all I mean is that this is squared, so we know that we have 2 of these, right? It's like a number squared, just the same as if we have 6 squared, that means 6 times 6. If we have terms in parentheses that are squared, that means we have 2 sets of those terms. So we have u plus 6 times u plus 6. What we're going to do from there is we're going to foil this. So if you're familiar with foiling or not, it's basically just a term for distribution. What we're going to do is distribute each of these terms to each of the other terms in the other parentheses. So that u is going to go, to that u, the other u, and it's going to go to that 6. This 6 is going to go to this u. This 6 is going to go to that 6. Okay, so when we do that, what we're left with is u squared, and u is squared because if we do u times u, variable times a variable, that gives us a squared. So it's basically like we add the exponents. So if this was 1 and 1, which imaginarily it is, when we have 2 variables, there's imaginary ones there, we add those up and we have 2. So that's where we get 2 from. Now u times 6, or u times 6 is going to give us 6u. 6 times u is going to give us 6u as well. And then 6 times 6 is going to give us 36. Where we get 6u from is if we get 6 times u. 6 times u is just 6u, okay? And 6 times 6 is 36. So that's our equation now that we unfoiled this. The only thing that we have to do next, remember we have to keep this in parentheses though, let's not forget about that, because there's one thing we have to do here that'll trip you up if you don't do this in the right sequence. So the first thing you want to do is separate out the terms. So you have it squared, so you put 2 sets of them. And the next thing you want to do is foil it like we just did, keep it in the parentheses, and now we're just going to distribute that negative sign, okay? So basically there's a negative, when you see a negative sign like that, there's basically a -1 multiplying everything that's in those parentheses. Now, you don't have to think of it that way necessarily. What you can think of is that you're just going to put a negative sign in front of everything that's inside those parentheses. So if we just rewrite the equation, so now we're going to have negative u squared minus 6u minus 6u minus 36, okay? Now we've distributed that negative sign. Now what we can do here, we see our equation got a lot longer. We have a lot of terms. Now we can figure out how to condense these terms. How do we do that? We do that by finding like terms. Now we're going to use a bit of that pre-algebra that we talked about the other day and do something like 6 minus 6. Okay, negative 6 minus 6. Remember from our pre-algebra, what is that going to give us? We add and keep the negative, so that's going to give us 12. In this case, it's going to be 12u. All I'm doing, why did I pick those numbers? Is because they're like terms. The u and the u makes them like. Okay. Now we're going to keep going and see if we come up with any other like terms. Okay. So what are the other like terms? Do we have a like term here? Yeah, we do, because we have a u squared here, u squared here. So that's basically, so 2u squared minus u squared is the equivalent of saying 2 minus 1, right? Because there's a imaginary 1 in front of that variable. So that's just going to give us 1. So we're going to have 1u squared, or just u squared. Now for this one, for b, right, in the series, which is a, b, and c. So b is 14u. Do we have another u? We still have another u, even though we took that and condensed that 6u. We have now negative 12u. Negative 12u, so if we have 14, now we have 14 minus 12, essentially, which is going to give us 2. So we have positive 2u. Now for our constants, these constants, yeah, they're like terms. So we can deal with those. How are we going to deal with those? We are going to say 33 minus 36 is going to give us negative 3. So now we have u squared plus 2u minus 3. And now we're back into a simple quadratic form. Where first we had our quadratic form here, but it was a little bit complex because we had this that we had to unfoil, right? But we had our quadratic form, but we had to deal with this first. We unfoiled that, we distributed, we added the like terms, we got rid of the negative sign, we distributed the negative sign, and now we're left back with another quadratic. Something that we can deal with very easily now. So now we just go back to our regular quadratic principles. How do we solve a quadratic equation? Well, the question to the quadratic equation is what number adds up to 2 that also adds up to negative 3? That's what we're going to ask ourselves. I'm going to write this over here. So for our quadratic, we're going to set this to 0. Let me move this over so we're not running into that over there. We're going to set this to 0. Always set your quadratic to 0. Again, when we're dealing with a quadratic, we know we're going to have two sets of answers that are going to come out of our parentheses. And the reason why we have two sets of answers is because we're going to factor this out, right? This is called factoring out. We're going to factor out the 2u minus 3. So again, the question that we're going to ask is, what number equals 2? What two numbers equal 2? So one number here and another here. What numbers, let's say A and B, however you want to say it, equal 2, and what the same numbers multiplied, what same numbers multiplied would give us negative 3, okay? So we need two numbers that add up to 2 and also multiply to negative 3, which is kind of a fun little question. Factoring is known to get on people's nerves when they're doing algebra, but sometimes it can be kind of fun and kind of intriguing questions because you can kind of see how numbers interact with each other. So, of course, there's not that many things that multiply by 3. So the easiest way to start with factoring is you do like a little tree. So you take your number that you're going to factor, and typically you're going to start with the one that you multiply, right? Because usually you can derive derive larger sets of numbers by what you're multiplying. You can break down that number in more forms. So we're going to break down that number into all the multiples of 3, which we really only have 1. So this one is pretty simple and fairly intuitive. You could probably figure it out in your head once you get used to this. So 1 and 3 really are the only things that multiply into 3. So, but if we do 1 plus 3, what does that equal? That equals 4. Okay, so that doesn't necessarily work. 1 plus 3 equals 4, but 1 times 3 equals 3 too, not negative 3. Remember, the value matters. So we have the same quantity, but not the value. So now we have to keep going. It doesn't mean our answers or our numbers are bad. Maybe there's something we can do with the sign. Let's say if we put a negative 3. So if we do 1 plus negative 3, going back again to our pre-algebra stuff. So 1 plus negative 3, we subtract, take the sign of the negative. That gives us negative 2. Okay, well, that's not going to work because we need a positive 2. If we multiplied negative 3 and 1, what do we get? Well, we get negative 3. So that works for the multiplication, but it doesn't work for the addition. And it needs to work for both. Okay, this needs to work for both. So that's not going to really work. Let's see if we flip the negative sign to 1 and see if that works. So negative 1 plus 3 equals what? That equals a positive 2. Subtracting the sign of the bigger number. The larger number is 3. Okay, so that keeps us positive. Now, we can go multiplication. Negative 1 times 3 gives us negative 3. It works. So those are our numbers. So we have negative 1 and 3, positive 3. So how are we going to write this? So our quadratic is going to always start with a variable, and we're going to put in our values that we found. So we found negative 1 and positive 3 are the values that if we foiled this, we would get back the same number. Now we can try that just really quick just to show you that you can prove the values that you got. So if it works, it works. So what we're going to do, we're going to foil this just like we did over there. We're going to do u to u and u to 3, and we're going to do negative 1 to u and negative 1 to 3. So if I do that real quick here, that's going to be u squared plus 3u minus 1u minus 3. And I just do u and just do the like terms, right? U squared, 3u minus 1 is going to give me 2u minus 3. So I'm back to the same answer. That's how that works, right? It's just broken down, but if you do it back, if you do it back, you can you find the same answer. So that just proves us that we got the right answer there. So we've got the right numbers. Now we're not done yet. We're not done completely because that won't give us exactly what we want for our quadratic. There's just one more step to do, and that is, again, treating these as if they're separate equations and setting them both to 0, then we'll get our answer. So what I'm going to do here is u minus negative 1 equals 0, and we're going to have u plus 3 equals 0. Okay, that's how we're going to find our quadratic. Now, of course, when you get used to this, you can do this intuitively in your head, and you can figure out what the numbers are. But I'm going to show you step by step here so we understand what's going on. So we have, for the first answer, we're going to have u minus 1 equals 0. How do we solve that? Well, we just do positive 1 on both sides to find out what the value of u is, right? Because we're still doing equations. We're still trying to find the value of u, just like if we did an equation of 5x plus 10 equals 20. We're trying to find the value of 5x, of the x there. Okay, so what we're saying here is what value times 5 plus 10 would give us 20. Okay, that's what we're asking when we're when we're trying to ask these questions. That x is a question mark. There's some value multiplied by 5 plus 10, which would give us 20. Okay? So here we're trying to find the value of u. We can do that just by doing that. So we take the opposite. So it was -1, we do +1 on both sides. That gives us a +1. So u is +1. And u could also be, we're doing the same thing here. So it's +3. We're going to do -3 on both sides. U equals -3. Okay? So how your answer is going to look like on a test, or if you're doing something online, how your answers should be answered, or should be entered rather, is usually in parentheses, and where you typically going to put the smallest number on the left side, separate it with a comma, and put your next answer. So u equals -3 and 1. So that's how you solve a quadratic equation. Thanks for watching. This is at the Symposium.